Classification of matter in a nutshell. So what is matter? Anything that has mass and takes up space is considered matter, but there are different variations of matter. So we're going to go into what those differences are. So it's basically classified based on whether you can break it down or not, and based on some of its properties. So let's take a look at this flow chart. So if it's variable in composition, which basically means does it made of more than one thing? If it's made of more than one thing, we consider it a mixture. And if it's a mixture, we have to ask ourselves, does it look like it's one thing, but it's a mixture, or can you tell the different parts by looking at it? That's the difference between homogeneous and heterogeneous. These are both mixtures, so be clear on that. They're both made of multiple things. The only difference is with homogeneous, you can't tell by looking that it has multiple things inside of it. It looks like one thing. You could know it's made of multiple things, but with your eyes, you can't tell. That's what homogeneous means. And you can see at the molecular level, there's multiple things in it, but you can't tell with your eyes. There's tea and sugar, but you can't tell. So we call it homogeneous mixture. Heterogeneous, on the other hand, you could see different parts. You could see rock, you see sand, you can see water. There's multiple things in it. That's what heterogeneous means. There's multiple things you tell by looking with your eyes. At the molecular level, once again, wet sand, you can see there's water molecules or sand molecules. There's differences. What if the composition is not variable? Then you call it a pure substance. And there's two types of pure substances. There's compounds, which can be broken down to simpler parts. So water, for example, can be broken down to H2 and O2 if you wanted to. And things that can't, which are called elements. Elements you can't break down any further. They're the most basic of building blocks. You can't get smaller than that. So based on whether you can separate the simpler substance or not, you can tell if it's an element or a compound. But both of these are pure substances. So when you identify something as a pure substance, you ask yourself, is it an element or a compound? How do you tell? If you could break it down, it is called a compound. If you cannot break it down, and what I mean breaking down, I mean chemically break it down, have it undergo a reaction, then we consider it an element. So that's the difference between the two. So that's the question you need to ask yourself. So pure substances, once again, they are not variable in composition. Mixtures are. That's the key difference between them. So they're made of a single type of atom or molecule being a compound. Mixture, on the other hand, is made of two or more elements or compounds. So they're a combination of different substances. It's not just one type of compound, one type of element. It's a mixture of multiple elements and or compounds. So looking at this more closely, so what's the difference between elements and compound? So elements only contain one thing. So you have helium, you have O2. You can't make this smaller. Now this is called an elemental compound, O2, because there's two O's attached to each other. But still considered an element. You can't really break it down any further. Chemically, you can't make O2 turn to O. It doesn't exist. With H2, on the other hand, we could break down H2O. We could make it turn to hydrogen and oxygen gas. And that's why this is called a compound and this is called an element. So once again, elements you cannot break down, compounds you can. Homogeneous mixtures and heterogeneous mixtures, so what's the difference? If you look at homogeneous, they're both, first off, made of multiple things. But for homogeneous mixture, they're uniform in composition. Like when you look at your eyes, you can't distinguish one part from the other. And that's what makes them homogeneous. Heterogeneous, on the other hand, you can look with your eyes, you can see different layers. Like here, you could see whatever the substance is, like sugar and then water. You could see them separate from each other, and that allows you to consider a heterogeneous mixture. So once again, homogeneous, it looks like one thing. Heterogeneous, it looks like you have multiple things. Just with your eyes, you can tell. All right, let's try some questions. Sugar water. So if you've ever had sugar water, you can't see sugar molecules inside. Now you could oversaturate it by putting so much sugar it doesn't dissolve, but that's not the same thing as sugar water. So just sugar water with sugar actually completely dissolved in water looks like it's homogeneous. It looks like one thing. You know there's sugar, you know there's water, two different things, but you can't tell by looking. So we could consider that a homogeneous mixture. So the same thing. You know there's multiple ingredients in it, but you can't tell those ingredients by looking at it with your eyes. So that's homogeneous as well. Penny, same thing. It's copper. It could be copper and zinc, depending on how old the penny is. Either way, it's homogeneous. You can't tell there's multiple parts. Los Angeles River, which is basically where all the storm drains are, you know for a fact that's not homogeneous at all. There's multiple things floating in that river. So we consider that a heterogeneous mixture because there's multiple things you can see with your eyes. Chalk and milk looks like one thing, so homogeneous. The ocean, whole bunch of things. Seaweed, sand, shells, everything. It's heterogeneous for sure. So that's the difference between those different substances in terms of homo and hetero. Let's try one more classification question. So what about sand? What would you consider it? Is it a pure substance, element, compound, molecule? Well, if you think about it, sand is a combination of different substances. So we consider it a heterogeneous mixture. You can see different layers to the sand. If you pick up some sand in your hand, you see some brown, you see some rocks, or different layers you can see. Granted, they're very small, but you can see them with your eyes. Ice, on the other hand, we know it's a compound, right? First thing you need to understand, anytime it's a compound, that means it's also a pure substance. Anytime it's an element, it's also a pure substance. It's actually going to be more than one thing. So it is a pure substance. It is a compound because it's two or more things together. And it's a molecule because both of the things are nonmetals, which you'll come to find out later based on if it's, metal and nonmetal or two nonmetals of different classifications. Here, we consider a molecule because they're both nonmetals. Flour, homogeneous, just looks like one thing. There's a bunch of stuff in it, but you can't tell by looking. And table salt, we have another compound. Here, it's a pure substance and a compound. Why is it not a molecule? Because this is called an ionic compound. Ionic meaning a metal and a nonmetal. Two nonmetals is a molecule. Metal and nonmetal, we consider ionic compound, not a molecule, and that's the difference. So that's matter in a nutshell, basically.